Okay, so in this video, I'm gonna continue doing more example on relative maximum, relative minimum, and saddle point using the second derivative test. Okay, so you have fxy equal to x cubed plus y cubed minus xy. Okay, so you're gonna do 4 steps. Okay, like we did in the previous example. So you have the first step. You're gonna compute fx. Okay, so you find the critical point by finding fx. So it's going to be 3x squared and minus y. And you have fy equal to 3y squared and minus x equal to 0 equal to 0. And you're gonna solve for x and y simultaneously. So in this case, you're gonna have y equal to 3x squared. Okay, so you have y equal to 3x squared, and you're gonna have x equal to 3y squared. Okay, so you have x equal to 3y squared. So you're gonna plug in. Okay, so you have y equal to 3x squared. So you're gonna plug into this equation. So you would get x equal to 3 and multiply with y, right? So this one will be your y and this one will be your y square. So you're gonna have 3x square. Okay, so this would give me 27. Okay, and you have x to the 4th. Okay, so you have x equal to 27, x to the 4th. So you get 27, x to the 4th, subtract by x equal to 0. So you get 27, x cubed. Okay, so you're gonna pull out x, right? So it's gonna be x 27, x cubed minus 1 equal to 0. So from here, you would conclude that x equal to 0, or you have 27 x cubed equal to 1, and you have x cubed equal to 1 over 27. This would lead you to x equal to 1/3. Okay, so you have two values of x, which are x equal to 0 and x equal to 1/3. Okay, so you have x equal to 0 and x equal to 1/3. So you're gonna put your x here into this function. So you're gonna put your x here into 3x squared. So you would have x equal to 0, you have y equal to 0, and you have x equal to 1/3, you have y equal to 3 1/3 square. So it would give you again 1/3. Okay, so you're gonna have 0 0 and 1/3 1/3 are the critical point. Okay, so you have x equal to 0, y equal to 0, and x equal to 1/3, y equal to 1/3, and you have 0 0, y equal to 1, and 1/3 1/3 are critical points in this case. So in this case, you get this one. The second step will be you need to compute the second derivative. So you have fxx, so you take a look here and there. So you see that fxx equal to 6x, okay? If yy equal to 6y, and you have fxy equal to fx with respect to y equal to -1. Okay, so you have fxx equal to 6x, fyy equal to 6y, and fxy equal to -1. Let me change the color. Okay, so you're gonna compute d in this case. So it's gonna be fxx, fyy minus fxy square. So it's gonna be 6x, 6y minus -1 square. So this guy will be 36xy minus 1. Okay, so you have d equal to 36xy minus 1. This one I will highlight green color. And I will need fxx in order to determine the critical point. And I will draw the table in the third step. So in the third step, you're gonna draw a table like we did before. So we have point, the fxx, conclusion, and value. So you have the critical point. Okay, so you have D, A, B, and you have fxx,a,b, okay, and you have conclusion, and you have value. So the critical point turned out to be 0, 0, and 1/3, 1/3. For d at 0, 0, you get -1, okay, and d at 1/3, 1/3, you're gonna plug in 9, so it's gonna be 4 minus 1, so you would get 3. So this guy negative, this guy positive. For the one that positive, you will need fxx, so it's gonna be 6 times 1/3 equal to 2. Okay, so it's gonna be 2. So it's 6 times 1/3 equal to 2 positive. Okay, and you have if here it's going to be negative. So for negative, you just conclude saddle point automatically without anything. Okay, so this guy will be just saddle point. Okay, so for the next one, you see that you have the positive, you have fxx, which is your A, positive. So this one will give you relative minimum. Okay, so this one will be relative minimum. And when you have relative minimum, you're gonna compute for value. So you need f 1/3, 1/3 equal to -1/27. Okay, so you have this table and you're gonna draw the conclusion. So the conclusion will be f has a saddle point at 0, 0, and f has a relative minimum, okay, at 1/3, 1/3 with the value -1/27. Okay, so this one will be all of the thing that you have to conclude. Okay, so this one is the whole picture for this question. So you see that every question turned out to be the same. I did like a 4 example already. However, I like you to see the aspect on solving for critical point. Some turn out to be easy, some turn out to be long, or some turn out to be difficult. Okay. The next one will be an interesting question. You have fxy equal to x to the fourth plus x minus y to the fourth, and you like to find the critical point. Do not expand this guy out, okay? So we're not gonna expand this one out in order to find the critical point. So we're gonna just differentiate using the chain rule. So you have fx equal to 4x cubed, okay? And plus you have 4x minus y cubed, okay? And you have derivative respect to x equal to 1. And you have fy equal to 0 plus 4x minus y cubed times negative 1. Okay, so you have this equation, and this guy turned out to be equal to 0, equal to 0. So in this case, you will have x minus y cubed equal to 0 from fy, and you see that you have x minus y equal to 0 by taking the third root both sides. So this allows you to conclude that x must be equal to y. Okay, so x must be equal to y. And after you know x must be equal to y, you're going to put into the first equation. So this will lead you to 4x cubed plus 4 times 0 cubed equal to 0, and you have x equal to 0. Okay, so you will have x equal to 0 after you know that x equal to y. So you're going to conclude that 0, 0 is the critical point for us here. Okay, so you have only one critical point, which is x equal to 0, and you so have y equal to 0. Okay, so this one is the critical point for this function. So you have only one critical point. The second step, you would compute fxx. So for fxx, it's going to be 12x squared, okay? And you're going to get plus 12x minus what? X minus y square. Okay, so this one will be your fxx. You have fyy. Okay, so you have fyy. So this guy will be minus 12 x minus y square times negative 1. Okay, so that's my fyy. And you have fxy. Okay, fxy is turned out to be what is called, it's going to be 12x minus y square times negative 1 also. Okay, so this one will be fxx, fyy, and fxy square. So you compute d for me. You have d, okay, xy turn out to be 12. Okay, so it's going to be 12x squared plus 12x minus y squared. Okay, multiply with 12x minus y squared. Okay, and you're going to have negative of 12x minus y squared like this. Okay, so this one will be your dxy. And the third step, that you see here is gonna be, you need to analyze 0, 0. So you compute, okay, so we're gonna compute d at 0, 0. You compute d at 0, 0, you see that it seems difficult because you have very long d. However, when you plug in x equal to 0, y equal to 0, it's turned out to be nothing left. So it's turned out to be equal to 0. And when you have d equal to 0, the second derivative, so the second derivative test is inconclusive. So you have any information on the conclusion yet? So it's inconclusive. Okay, so you not be able to conclude anything yet. Okay, because d at 0, 0 turned out to be 0, 0. So we need to like do some analysis here. So you have fxy. Okay, so we need to analyze our function, the function on, right? We need to analyze our function by ourselves. Okay, so we need to analyze our function by ourselves. So you take a look at your function. You have fxy. Okay, so since fxy is given by x to the fourth plus x minus y to the fourth, this guy is always positive. Positive. Okay, is always positive or 0. And if 0, 0 equal to 0. Okay, so in this case, so we have fxy is always positive or 0, and f0, 0 turn out to be 0. So we have 0, 0 is a relative minimum. Okay, so we're gonna be able to conclude that this guy is a relative minimum because what? Because you know that fxy is always positive or 0, right? Greater than or equal to 0. And you see that f0, 0 is the one that lowest, okay? Is the one that lowest. So in this case, you have 0, 0 is the relative minimum for this function. Okay, so this is how we gonna conclude. Okay, so you see that this one is the fourth step that different from the other question because it's turned out that the second derivative test is inconclusive in this case. Okay, so we need further analysis, and the way to analyze is going to be just you have to take a look at the function directly and you conclude from it. Okay. Okay. The next one is you have fxy equal to e to the xy. Okay, so you're gonna find the first step, which is the critical point. So you compute fx for me. So it's gonna be e to the xy times y, and fy turned out to be e to the xy times x. Okay, and you have equal to 0, equal to 0. So in this case, you're gonna have y equal to 0 from the first one because e to the xy never, okay, so when you have e to something here, never equal to 0, never be 0 is never be, okay, so let's write this one, not, okay, so e to anything turn out to be not equal to 0, so you have y equal to 0, and you have e to the xy times x equal to 0, so you would lead to x equal to 0. So from here, you would get 0, 0 is a critical point. Okay, so it's gonna turn out to be one critical point in this case. The second step, you're gonna compute the second derivative. Okay, so this one is a little bit tough. So you have fxx. So you see that you need to compute the second derivative. So it's going to be y e to the xy times y. Okay, and if okay, if is going to be x e to the xy times x. And you have f xy, so it's going to be the first derivative of the second, which is 1, plus the second derivative of the first, so it's going to be e to the xy times x. You differentiate with respect to y, don't forget about that. So it's going to be e to the xy plus xy e to the xy. Okay, so you're gonna compute dxy in this case. So it's gonna be the product. So it's gonna be y square e to the xy multiply with x square e to the xy minus you have e to the xy plus xy e to the xy square. I would say that do not simplify because you don't need to simplify d. Okay, the thing that you need to compute in the third step will be you need to compute d at 0, 0, and it's turned out to be computable in this case. So d at 0, 0 turned out to be minus 1. Okay, so turn out to be minus 1, which is smaller than 0. So it's in the case that we would have a saddle point. 0, 0 is a saddle point. Okay, so you conclude that 0, 0 is a saddle point. So we're gonna conclude in the last step that f has a saddle point at 0, 0. Okay, so it seems difficult. However, for this one, it's not that difficult. The difficult part here turned out to be on the second derivative. And like I said, do not simplify for d, just plug in the value of the critical point, okay? And it's going to allow you to conclude that quite easy. Okay, for the last one, before we go to the word problem, so you have fxy equal to xy plus 4 over x plus 2 over y. Okay, so in this case, you're gonna compute fx. Okay, so let's do the first step up here. So you have fx equal to derivative with respect to x turned out to be y, and you have minus 4 over x squared. Okay, and derivative with respect to y turn out to be x minus 2 over y squared. Okay, so for this one, you allow to solve for y, so it's going to be 4 over x squared, and you would plug y into this equation. Okay, so this one I forgot, equal to 0. Okay, sorry. So this guy equal to 0, and you solve for y, and this guy equal to 0, and you solve for y. Okay, so you would have, okay, so from here you would have x equal to 2 over 4 over x squared, and then square. Okay, so this will allow me to have 2 over 16 x to the 4th. Okay, so this one will be, you see that x cannot be 0 because x is already on the bottom here. Okay, so this one, x cannot be 0 for sure. Okay, so you're gonna just have x cubed equal to 1/8. Okay, so you're gonna have x cubed not equal to 1x, so you're gonna have x cubed equal to 8. Shoop, shoop. So you gonna have here, okay, so you have x cubed equal to 8, and so you would get x equal to 2. Okay, so after you have x equal to 2, you would plug into here for y, and this allows you to have y equal to 1. Okay, so you have y equal to 1 and x equal to 2. So you solve this guy, and you're gonna conclude that 1, 2 is the critical point. Okay, so you have 1, 2 is the critical point. So for second step, okay, for the second step, you need to compute the second derivative fxx. Fxx for me is gonna be to come down, so it's gonna be 8 over x cubed. Okay, so that will be fxx. Fyy is gonna be negative, so it's gonna be 4 over y cubed. Okay, and if xy, okay, if xy turn out to be what? If xy turn out to be 1. Okay, so turn out to be 1. So d will be dxy equal to 8 over x cubed, 4 over y cubed, minus 1 square. So it's going to be 32 x cubed y cubed minus 1. Okay, so that's my d. And then you compute the third step. So you compute d at 2, 1. No, not 2. 2, 1. Yeah, 2, 1. 2, 1. Okay, not 1, 2. D at 2, 1 will be 32, 2 to the third, 1 cube minus 1. So it's going to be 4 minus 1 equal to 3, okay, which is positive. And you have fxx at 2, 1 turn out to be 8 over 2 cubed equal to 1 positive also. So if you have d positive and fxx positive, so you see that 2, 1 will be relative minimum. Okay, so you have 2, 1 is a relative minimum in this case. Okay, so you have 2, 1 is a relative minimum, and the fourth step, okay, and the fourth step will be the conclusion that f has a relative minimum at 2, 1 with the value equal to f21, right? F21. So you plug in x equal to 2, y equal to 1. So it's going to be 2 plus 2 plus 2 plus 2. So it's going to be 6. Okay. So that would be it. And this one will be the end for this lecture. Okay. So I did like many example already. So the next clip is going to be about the word problem for this topic, about the word problem for maximum and minimum value, that we're going to read the question together, and we're going to formulate the function and find the critical point. Okay, so that's all.